Hello everyone, welcome to Pratibha Tech. In this video, we will solve the problem of the day question on Geeks for Geeks for 3rd March 2023. The problem statement for today is cutting rectangles. This is based on some mathematical algorithms and this has been asked in Amdocs interview question. Let's now open this problem. First, we'll try to understand the given problem clearly. Here it is said, given a rectangle of dimension L into B, find the minimum number, that is n, of identical squares of maximum side that can be cut out from the rectangle so that no residue remains in the rectangle. Also find the dimension k of that square. So here it is simply said, with the given rectangle of dimension L into B, we have to find how many squares we can cut out so that there is no residual left in the rectangle. And we know that the squares are of equal size, length and breadth are of the same size. And we have to find even the dimension of the square. So for example, it's given for L is 2 and B is 4, that is length is 2 and breadth is 4. So the output here is n is equal to 2 and k is equal to 2. That means we can cut out 2 squares of 2 into 2 dimension. In the other example, it's given length is equal to 6, breadth is equal to 3. So here we can see we can cut out 2 squares of 3 cross 3 dimension. Let's understand it more visually. Suppose we have been given this, I have taken this one for the second example. Here it is said length is 6, breadth is 3. Then we have to find the square of the maximum size. See that here this line is very much important here, that we have to find identical square of maximum side. So for that reason, here we can see if we have length is equal to 6 and breadth is equal to 3. So the only possible way to find is that we have to divide it by this line, saying that two identical squares have been formed, one with this 3 cross 3 and another one with again this 3 cross 3 size. That means in a square we have only one dimension, so yeah, dimension will be 3. If it was not given in the question to find dimension with that identical square with the maximum side, then we could have easily divided into 1 into 1, 1 into 1, 1 into 1, 1 into 1. Yeah, but that is not the question here. Here the problem statement says we have to find identical square of maximum side out of maximum side which we can obtain to form the identical squares here. So if you can see with this input L into B, so how we are reaching there? We are getting a dimension of 3. So out of 6 and 3, so how we are obtaining the 3? So we are using here the approach of GCD, that is greatest common divisor. Okay, so the reason we use GCD algorithm here is that we are trying to find the largest square which can divide both length and breadth of the rectangle without any remainder. Even this is the same thing has been even asked in the problem. In other words, we are trying to find out the largest common factor of length and the breadth. The GCD algorithm is well-known algorithm for finding largest common factor of two numbers. We use GCD algorithm to find GCD of length and breadth of the rectangle. Once we have the GCD, we know that we can cut out a square of that size from the rectangle without leaving any residue. We also know that the number of squares that can be cut out is simply the product of length into breadth, that is of the reduced size. That means reduced length into breadth. That means if you are given 6 here, if you are given 6 here and this one here 6 and length is 6 and breadth is 6, and if you get GCD as 3, so how many rectangles how many squares we will obtain? We will simply divide both these numbers by GCD and we will just do a multiplication of it. So we will do 3 by 3 and 6 by 3. So here we will get 3 by 3 and 6 by 3, so you will get 1 into 2, 2. So that means the number of square that we will get will be 1 cross 2, that is equal to 2. Okay, I hope so this is clear. So I'll just show the code wise that how we will obtain the GCD of a given number. So suppose so this is the standard code of finding GCD of a number. So here what we'll do, suppose we are given two input as A and B. So first we will check if B is equal to 0, then return A. And in which scenario this B is equal to 0? For that we have this recursive call here. Here it is said that find GCD of B comma A modulo B. A modulo B means it will simply indicate if that number, if one of the number is divisible by the another one. If that is the case, then we will pass the smallest one first and this one, and the modulo of both the numbers in the second parameters, and we will check if the second parameter is 0, then return A. So here in this case, here A is equal to 6 and B is equal to 3. So here we will check B is equal to 0. No, it's not equal to 0. Then we will go to this recursive call and we'll see if we'll pass B and A modulo B. So here in case of 6 and 3, here B will become 3 here, and A modulo B, that will be 6 modulo 3, will be 0. So next time we'll get, yes, B is equal to 0, then return A. Return A, that means return 3. So that is the GCD. So this was one of the simple example. If we take, suppose here the example of 24 and 16, that means length is 24 and breadth is 16, then what we can do, here we will see, here A is 24 and B is 16. Is B is equal to 0? No. Return A. So this won't be executed. Then in the next recursive call, we will do GCD of B, that is 16 and A modulo B. A modulo B is 8, because if we divide 24 by 16, the remainder will be 8. So next time it will go here in this one, and it will again check if B is equal to 0. No, B is here 8, it is not equal to 0. Then again it will go to this recursive call, and again it will, this time it will find GCD of 8, and here this time here A was 16 and B was 8. So if you do 16 modulo 8, this time we'll get 0. So when we are calling this GCD method with 8, 0, then here it will check if B is equal to 0, yes, they return 8. And here if we, with this number, so the GCD will be 8 here, and if we look at this number, then we can clearly see in 24 and 16, 8 is the maximum number that can divide both these numbers. So that is the GCDs, and the significance of finding the GCD that I have already discussed here, that if we get the GCD, then we can divide both length and breadth by that number, so that we can get that square, that means the size of that square. And how many squares we get, then we have to divide both these things, that means 24 by 8 and 16 by 8. So it will be 3 into 2, that means 6 numbers of square of dimension k8. I hope this much is clear. So now let's start coding. That means whatever we have discussed, we will code that way. So just to save time, I have already typed it. So the same thing, whatever the approach we have discussed, that only is there. So here I have simply created a return type of list long. That means return type of list long to store the resultant, and for that we are calling find GCD method with the input given to this problem, that is L and B, and whatever the GCD we get, for calculating GCD we have taken the same code which we have discussed in a minute ago. And once we get that GCD, so after getting the GCD, so what is that? That is that side, that means the side value, that means the length of the side of each square. And how many squares we'll get? For that, again, the way we divided 24 by 8 and 16 by 8 and we multiplied that. So the same approach we have taken here as well. So L by GCD into 8 by GCD. That means, L by GCD and B by GCD, which is 24 and 16, both divided by 8 and 8. So that way we will get here 3 and 16 by 8 is equal to 2 here. So we will get minimum 6 squares of dimension side, which is this one GCD of, and that will be 8. So both these things we are adding it to the resultant list, and we are simply returning that list. This is that simple. See, for some people this part is clear through this statement, but some of them understand it better with this statement. That means if you so what the difference between these two? Here you divide length by GCD and breadth by GCD, and in the below statement it is finding the area of the rectangle, then divided by area of the square, so that we can find that how many minimum number of squares that is possible. So either of the approach is fine. It is just the reshuffling of the variables from here and there, but yeah, result will always be the same because the operations of only multiplication and division. So yeah, so that's it in this coding part. So now let's try compiling this code. So here we can see we have got our output correctly. So let's try submitting this solution. So here we can see we have got all the test cases covered here. So talking about the time complexity of the above solution. So here it is the big O of log of min of ln(b). Minimum of ln(b), that is the input which has been given in the question. So it is a minimum because each time we are taking the from the minimum one. If in this GCD method we are reducing it by doing the modulo, and each time if it is see, suppose if the input were 6 and 3, so we can directly say that 3 is the GCD. So for that reason, the minimum of length to breadth. So either of those number, whether it is L or B, that has to be divided by the GCD. So for that reason, this is because the complexity of find GCD helper method, this one is big O of log of mean of A and B, that is L and B, where L and B are the input to the function. In the minimum square method, this one we call find GCD method with L and B. Therefore the time complexity of this method will be even the same. The rest of the operations in the minimum square function takes constant time, so they are not impacting the overall time complexity. So overall time complexity will be again the same. So that's it in this video. I'll be providing the link for this question in the description box. Please do check that. That's all in this video. Please like, comment and share the video, and please subscribe to the channel for more upcoming videos. Thank you for watching.